All right, I'm Adam Reznechek. I work at IBM, and I'm here to talk a little bit about OpenStack and the power systems and the new ecosystem that we've been building up as part of that, as the part of the OpenStack compute platform. So we'll go on to the next slide here. So what is power anyway? There's probably a few people here in the crowd that haven't heard of power before. Power, the TLDR, as I put in the first line, is that power is a server line and a processor architecture that was created by IBM. It was originally formed back in 2008 by a merger of the System I and System P server lines. There's two separate lines that IBM had going, and is really focused primarily on servers. They're really built for things that are high performance compute and I/O acceleration, things around enterprise, HPC, cloud markets. So really these kind of higher, mid-range to high-end systems that we have out there. And I mean, it's powered other things in the past. You might recognize some other things that have run power processors like the Xbox 360, the PS3, the Wii, and the Wii U all run on power systems processors. But today it's primarily focused on the mid-range to high-end server market. Now, one place that power has really gone in the past couple of years is that we have this new initiative called Open Power, which is a collaboration between over 100 different companies now that are specialized systems. So people like Google, Rackspace, NVIDIA, IBM have all come together to really create this new collaborative platform where you can come and you can license the power processor architecture and IP pretty freely, and then go out and essentially create your own processor designs, your own server designs, really customize it for whatever market you're doing. So one thing that's been going on is with NVIDIA, they've been doing a lot of work around integrating GPUs into the boards directly for acceleration. So that's a big thing that's been going on for the past couple of years, and there's a lot of excitement and interest going on there. And I think that's really it to cover on a high level what power is, so we'll go on to the next slide here. So just like x86, the Intel platform that's out there today has multiple hypervisors you can run on it. Power platform also has two hypervisors that you can do on it. It has the PowerKVM and PowerVM. PowerKVM, as you can see here in the picture, runs just like KVM does on x86. It's pretty straightforward. It's a fully open source KVM hypervisor. You manage it through libvirt. You pretty much can deploy standard tools against it just like you do with all of the other KVM that you would use on x86 today. In terms of OpenStack, it uses the Nova libvirt driver, so it's pretty much exactly the same kind of setup you would use as part of your libvirt KVM x86 setup today. So it's pretty straightforward. It has a fully functional third-party CI that's out there and runs against every Nova patch set out in the community. And it is today, just because it's KVM x86 or KVM power, it is fully RefStack compliant, so it meets all of the requirements that have been set as forth as DEF core. On the flip side, we have PowerVM. So PowerVM is a proprietary IBM hypervisor, and it actually runs as part of a firmware installed on the system. It's managed through a new piece of technology that we've just introduced that I'll cover in more detail on the next slide, called the NovaLink API. And it is managed by the Nova PowerVM driver. It has a third-party CI that's currently under construction. We're building that up right now internally, and we're working towards DEF core and RefStack compliance as well. So like I said, for PowerVM, we're kind of back again with this new architecture called NovaLink. There was previously, for full disclosure, a PowerVM compute driver that was integrated into Nova before. It was there. It was on a platform that had a very limited set of features. That driver was eventually deprecated about 2 years ago. We're back with a fully new architecture and a full new compute driver that's built on top of this new piece of technology called NovaLink. And NovaLink is a completely new management framework for PowerVM. It is a fully managed REST API that's available for the platform, so you can do all of your virtualization management similar to like what you do through the libvirt API for KVM. It uses a Zen-like model, so if you look on the left, you can kind of see it runs as VM1 essentially on the server. It runs all of the services inside the VM, and you can manage it through the REST API. You can run the compute, network, telemetry services on the system, just like you would with any other platform. It's actually built on Ubuntu, so it's a completely open platform. You can just go and install anything as you would on any other platform. And then support for other distros is something we're looking at, so things like Red Hat's going in the future. And all those API services that I talked about are available as just Debian packages you install on Ubuntu, and they're all there as part of the platform. As part of the project, there's also this open source library called PyPowerVM. PyPowerVM is basically equivalent to the Python libvirt library, but for Novalink. So it's all out there on GitHub. I have a link to it up there, but it's really just a general purpose library to do Python management of PowerVM systems through the Novalink API. And it's consumed pretty heavily through our drivers as a way to kind of simplify what's actually required in terms of the logic that's in the drivers themselves. Our drivers, we have 3 of them that are kind of set up out in the community today. They're all previously part of StackForge. They've transitioned into the OpenStack namespace here now. Compute, we have the Nova PowerVM driver. This is similar to like your other Nova drivers that you have out there. It's out there. It's a out-of-tree driver right now, but you can go and install it on a system, and it's compatible with all other hypervisors, so you can have a OpenStack running a PowerVM system through Novalink. You could have KVM, you could have x86, you could have VMware, whatever you want to have up there. It works at the same time as PowerVM. For network, we have our layer 2 networking driver that's through ML2. That's out there as networking PowerVM. That's actually an officially approved subdriver under Neutron now, so you can go out and install the plugin and it works. And for telemetry, we have integration with what's called Ceilometer PowerVM, and really that's just another project for Ceilometer that you can go in and have metrics gathered as part of a hypervisor inspector for PowerVM. The same way you do hypervisor inspectors for KVM, libvirt, for all of the other hypervisors. So really one of the goals of this project has been to get PowerVM to be as closely matched and as closely consumable as a hypervisor as all of the other things, really just to fit in with the community. It's kind of in some ways boring by design because its goal is to just work, just to drop in. And so I have a link there at the bottom where you can find out more about Novalink. We've recently announced the feature for the platform. It'll ship as part of a firmware release that comes out later this year as part of the hypervisor. But it's really, like I said, just the goal is to kind of bring PowerVM up to par, get it out there, get drivers out in the community. We're working with the Nova team and all of the other driver teams to get merged into Tree. We'll have a fully functional third-party CI that runs out as part of our drivers, and it really will just allow you to introduce Power and PowerVM systems alongside your PowerKVM and all other hypervisors that run as part of your heterogeneous cloud. And that's actually all I had. So.